We left off with number 3. I kind of said it was going to be similar to number 1, right? They're giving us that cosine is 7/25, which we talked about as adjacent over hypotenuse, and sine is greater than 0, so that's positive. So we are able to set up a first quadrant triangle. That means everything's positive. We were able to find y is 24, or our missing side is 24, the opposite. So sine, opposite over hypotenuse, was 24 over 25. Cosine, adjacent over hypotenuse, was given as 7/25, right? And then we were asked to find 3 half angle. So the first one we're being asked to find is sine of theta over 2. If you look at the front of your page, there is an identity for that, yes? Yeah, what's that identity for sine of theta over 2?
Plus or minus square root of 1 minus cosine theta over 2.
Plus or minus square root of 1 minus cosine theta over 2. Okay, we good?
Yeah.
You guys know the drill. Fill it in, yes? Now, that plus or minus out front, that is a decision you have to make. Okay, we're trying to find sine of theta over 2. Theta, if you recall, is this angle here. If you take this angle here and you divide it by 2, what quadrant are we still going to have to be in? We're in quadrant 1 right now. You take that and divide it by 2, well, we're still going to be in quadrant 1. So we can decide that these are going to be quadrant 1 answers, which means we're going to have a positive answer here. Okay, so you can drop the plus and minus and just realize it's going to be positive. 1 minus, what are we using for cosine of theta?
7 over 25.
Provided with 7 over 25. And then all over the denominator of 2 and all under the radical. Now, a couple of different ways you can proceed from here. We've got to clean that mess up, right? I probably would say, what is 1 minus 7/25? And what is 1 minus 7/25?
8.
Yeah, because we'll be doing 25/25 minus 7/25. So we're going to have 18/25 divided by 2. How do we do 18/25 divided by 2?
18 over 25 times 1.
Okay, dividing by 2 is, we're dividing with fraction, multiplying by the reciprocal. So still under the radical, I can say 18/25 instead of dividing by 2, it's multiplying by 1 over 2. Basic fraction stuff. Multiply and reduce, or cross cancel and multiply. Either or. One way or another, you get the square root of 9/25. And what is the square root of 9/25? 3/5. So we know that sine of theta over 2 is equal to 3/5.
That was wonderful.
Not too bad, right? Okay, so it's just filling in the information. We already did the starting part yesterday where we had to find what are the pieces we're going to need to put in. Okay. Well, that was sine of theta over 2. What else do we need to find? Okay. Cosine of theta over 2. That's identity on the front. What is cosine of theta over 2?
Square, or plus or minus square root of 1 plus cosine theta.
Okay, plus or minus square root of 1 plus cosine theta over 2. Be careful not to run out of room. We do still have to do tangent, right? I'm saying that because I'm running close on room, so just beware. Okay, plus or minus. Well, again, we're working in quadrant 1. Everybody's positive in quadrant 1. Sine was positive, cosine's positive. So this is going to be the positive square root. 1 plus cosine theta. What is cosine theta? 7 over 25 divided by 2. What else can we do?
Clean up the top.
Okay, 1 plus 7/25.
32/25.
Okay, 1 is 25/25. 25/25 plus 7/25 is indeed 32/25. Still divided by 2, still all under a radical. And 32/25 divided by 2, multiplied by the reciprocal, so 32/25 times 1/2. Me personally, I'm going to cross cancel or multiply and reduce. One way or another, you get the square root of 16/25, and the square root of 16/25 should definitely reduce to 4/5. And this is cosine of theta over 2. And one more. Tangent of theta over 2. Grab your identity, which is
Sine theta over 1 plus cosine theta.
sine theta over 1 plus cosine theta. This identity has a different look than the other two, but it's not any different, any harder to work. Okay, sine is 24 over 25 over 1 plus cosine, which is 7/25. What do you see as a step?
Clean up the bottom.
Okay, add those they're not fractions, but add the denominator, yes. So we're still going to have 24/25 divided by, what is 1 plus 7/25?
32.
My gosh.
Because again, we are adding 25/25 plus 7/25.
I opened my water bottle and water squirted out.
A little
Everywhere.
pressure built up in the water. Okay, 24/25 divided by 32/25 means you know what I'm going to do, right? 24/25 divided by, I'm going to change to multiplication. I'm going to do the reciprocal, which is 25 over 32. I'm definitely a cross canceler in this situation. I'm not multiplying those big numbers and then trying to reduce them also. Granted, I know we have calculators, but the obvious is the 25s reduce. Now, if you want to multiply, okay, you have 24 over 32. Reduce those. And we end up with 3/4. Because 24 and 32 both divide by 8. Okay. Those are the half angle identities.
That wasn't too bad.
No,
Is the next one bad?
I don't know. I don't remember. Next one isn't too bad once we get into it. We just have to get into it. Okay, one more example. Okay, example 4. Specifically, use the half angle identities to find the exact value of sine of 3 pi over 8. Okay, so we're being asked to use the half angle identity. Well, half angle identity we're being asked to find sine, yes? So first of all, what is our half angle identity for sine?
1 minus cosine pi, basically. U. Do we have to see?
Plus or minus square root of 1 minus cosine u over 2. You can change it off of u if you want. Okay? Now, there is the half-angle identity we're being asked to find, yes? And here's the deal, or being asked to use. And we're being asked to find sine of 3 pi over 8, yes? Because here's the catch on this, or what you have to make sure of, is we have to figure out what is it we're going to use for u. Okay, this whole fraction 3 pi over 8 is not u. Because what we've got to look at here is that we're being asked to use sine of u over 2. We're being asked to find sine of 3 pi over 8. Right here, u over 2 and 3 pi over 8 are in the same place. So I kind of look at it as, okay, we have to figure out what u value, when you divide it by 2, will give us the 3 pi over 8. Now, easiest thing I can say is to take these two right here and set them up as equal to each other. So if I set u over 2 equal to 3 pi over 8, because they're in the same position, right? They're both in sine. Can you solve that to find u? How can we find u? Yeah, if it's u divided by 2, we're going to multiply by 2. So that means we're going to end up doing u as 3 pi over 8 times 2. When we multiply by 2, you're multiplying best by 2 over 1, yes? What do we get when we multiply 3 pi over 8 times 2? 6 pi over 8, which becomes? 3 pi over what?
3 pi over 4.
3 pi over 4. Okay. That right there is what we're going to use as u. So, in other words, in order to find sine of 3 pi over 8, we're going to do sine of 3 pi over 4 divided by 2. Okay? So here's my thought process. We were asked to find sine of 3 pi over 8. But we need to use a half-angle identity. So I'm going to set it up as sine of what did we just come up with?
3 pi over 4 over 2.
Pretty much. 3 pi over 4 divided by 2. Now, the short of this is I kind of took you through the reasoning. But every time you go to use a half-angle identity in this scenario, what are you going to have to do with the given angle? Well, it's u divided by 2, so you're actually going to always have to double it. Okay, you're always going to be multiplying by 2 to get a value that is equivalent when you divide it by 2. Okay, so the idea here is that this right here is your u value when we fill it into our formula. So, our formula is plus or minus the square root of 1 minus cosine u. What am I putting in for u?
3 pi over 4.
3 pi over 4. And then all over 2. Are you guys with me there? Okay. From here, it's kind of the basics. Okay. It's getting that set up, and again, you have to double that value. Okay. Let's see. So one thing we're going to have to decide is plus or minus. What is it we're trying to find the value of? Sine of 3 pi over 8? What quadrant is 3 pi over 8 going to end up in? Think about some of those other common fractions as 8s, because I know you don't see 8s on the unit circle, do you? Like we know pi. Pi is how many 8s? 1 pi is 8 8s, yes? So it's before 8 8s.
Oh, so quadrant 2.
Well, if it's before 8 8s, it's quadrant 1 or 2.
Yeah.
How do we decide if it's in quadrant 1 or 2? What's pi over 2?
4 pi over 2, so quadrant 1.
Pi over 2 would be, or
4
pi over 2, 1/2 pi.
4 pi over
1/2 is 4 8s, yes?
Yeah.
Where is 3 8s in relation to 4 8s?
4.
Before it. So have I sold you that we're talking quadrant 1 then?
Yes.
Okay. Use those common denominators to place it. Think, okay, where is it? I start with pi because I didn't want to give it away, and pi is easy. Okay, but pi over 2. Okay, well, if pi is 8 8s, pi over 2 is 4 8s. And we know 3 8s is before 4 8s. So we know that we are in quadrant 1. If we're in quadrant 1, we know that we're going to have a positive square root. 1 minus. Okay, guys, we did something like this the other day. Cosine of 3 pi over 4. Where is 3 pi over 4?
Quadrant 2.
It is in quadrant 2. 3 pi over 4 is not on my chart there, is it? What reference angle is 3 pi over 4 the same as?
Pi over 4.
Pi over 4. So what I want you to do is tell me what is the cosine of pi over 4?
Square root.
According to our chart, it is square root of 2 over 2, yes? And you don't necessarily have to write this down. This is up to you. So then, how do we do cosine of 3 pi over 4? To do cosine of 3 pi over 4, we ask ourselves, what is cosine of pi over 4 but in quadrant 2? So if cosine of pi over 4 is square root of 2 over 2, what do we know about cosine in quadrant 2? It's negative. So we know that this is going to be equal to negative square root of 2 over 2. Right? That's at unit 4. That's supposed to be old news. I know we forget it. We don't remember it, but that's what you're supposed to be doing there. Okay, fill this in. So we're doing 1 minus negative square root of 2 over 2, all divided by 2. Okay. We have two options of where to go here. First of all, what do you know about minus negative?
Plus.
It is plus. So we can hopefully definitely agree that this is 1 plus square root of 2 over 2 divided by 2.
Can you add the top so that you have one fraction on top?
You can. Okay. I'm debating if that's the easiest route to go or not. I'll be honest, it's what I used to always teach, and I've realized that there's probably a slightly easier route. But one option, what have we been doing with the others? We were adding them on top or bottom, yes? And I agree that is doable. Okay. What's the other option of how do we get rid of fractions within fractions? Yeah. So what denominator do we want to get rid of? We want to get rid of that 2 right there, yes? How do you get rid of a denominator of 2? You're going to multiply by 2. Now, if I multiply the numerator by 2, multiply the denominator by 2. The other way is good too. I just think this saves us a bit. So now that 2, of course, on top is going to have to distribute, right? So on top, what happens? 2 times 1 is 2 plus, what about 2 times square root of 2 over 2?
Square root of square root.
Right? Because this is 2 over 1. The 2's cancel and you have square root of 2. All over, what's in my denominator? 4. So I have the square root of 2 plus the square root of 2 all over 4. One simplifying step will get us to the final answer.
You can't simplify 2 over 4, can you? You can.
Well, you'd have to simplify, you'd have to break it into 2 fractions.
Yeah, that's what I was thinking.
But we don't want to do that.
Oh, wait. Never mind.
The square root of 2 is in this 2.
Oh, you can take
The square root of what?
2.
The square root of,
Take the square root
the
of
square
4.
root of
the square root of 4
is 2.
is 2.
And then just move the square root to the top.
Right, so that denominator is a nice, neat, perfect square. And here's the deal, we don't like to have square roots in our denominator. And so we can just take this as on top, the square root of 2 plus square root of 2, and then all over 2. Okay? That is one way you could see the answer. I will also mention, they sometimes like to pull this 2 out front. And if you pull the 2 out front as a fraction, you will also see this as 1/2 times the square root of 2 plus square root of 2. I kind of probably favor the first one, but they're both good. Okay? Okay, guys. Parts of homework are going to be okay. Parts of them are going to take work. Okay?
Like this.
Yeah.
Okay.
Okay?
That's fine.
We will have to talk questions. That is for sure. It's one of those homeworks we'll definitely have to talk questions. So,
What? Are we gonna quiz before spring break?
nope.
Oh, thank goodness.
We're going to test after spring break.
Test, no quiz?
No quiz.
Okay, that's fine. That's fine.